So I finished my first Arduino project. It was a challenge. It was interesting. Essentially, for those that don't know, an Arduino is a little microcontroller that you use to attach sensors to, and you can, it's basically like a pre-built electronics rig that you can use to do things like automate things, build robots. It's a beginner's guide sort of to electronics, but the thing about them is they're really handy. So you can quickly knock up something electronic that can, automate your home, or it can, you could create a robot arm with it or do a whole bunch of stuff. And it's just an interesting tool to learn how to use. So I got one and I sort of put together a basic, my first little project that I sort of came up with on my own. And, rather than, I thought I'd learn more if I sort of came up with my own project rather than just finding one online and copying it and stuff like that. So essentially, it works like this. I'll show you basically how it works. This is an Arduino. This is an Arduino Nano. You can see there, 3.0. This little thing is the brains of the operation. It's essentially a prototyping board. It's got like LEDs to tell you what's going on the actual board, a USB plug. That's the main brains chip sort of thing, a reset button, and then on the other side, this particular model has pins soldered on, or soldered into it, I should say. You can get them without it, so you can just solder wires directly to the board. But this is for prototyping. So you have these little jumper cables that you send over to your particular modules, right? Which you can buy separately, or you could build your own. But if you want to knock up again something really quickly, you just buy the parts and put it together and write a little bit of code and you make it work. So the idea of this is actually you can then, once it's uploaded, you can unplug from the USB and you could apply your own power source like batteries or something like that. And you could have an autonomous little computer that just runs a cycle of code over and over, doing that one task that you programmed it to do. One task or many, depending on how you work it. But yeah, so at the moment I don't have any other power source, so I'll leave it plugged into the computer, but just imagine that you could have that separate, in a little box or something, Okay, in this particular project, I was trying to come up with something that I might be able to install in a guitar that could be cool. This isn't the end idea. I just wanted to learn the basics of how to operate the system before I tried anything more difficult. So this module right here is a microphone with a little tiny preamp, and there's 3 different terminals there. You got analog output, digital output, which basically detects if there's a signal or not over a certain threshold. The analog one just is a general microphone signal. You've got your power and you've got your earth. So that all goes from there into pins on the board. And this is an RGB LED. So this can actually be a red, green, or blue. Well, actually, I should say it has a red, green, and blue LED inside the little module there. And you can mix colors by creating any mixture of amplitude of any of those 3 LEDs. So you can make purple by mixing red and blue together, values and stuff like that. So what I wanted to do was come up with a way of, at this stage, detecting the output, the analog output of the microphone, and then writing some if statements to determine the amplitude of that signal, and then make the LED change color depending on what it is. So I set up some code here. So this is basically what you're looking at. You sort of have to interface the software with the board, let the software know what the board's doing, what it's outputting, naming a few variables, and then some if statements saying, for example, if the gain level, which is just a variable I made up, is below 100, then turn all the LEDs off. If it's above 100 and below 150, then we light up the blue LED. Again, if it's above 150 but under 200, then it goes green, and then if it's over 200, it'll go red. These numbers are pretty arbitrary because there's a gain control on the microphone, so I can adjust that up or down, and then these values would need to change to determine the sensitivity essentially. But as you can see, if there's very little noise under the noise threshold, there's no light. If there's noise, testing, 1, 2, 1, 2, 1, 2. So I can't get the volume quite loud enough in here, but it basically cycles from nothing to blue to green, and then to red if it peaks out, essentially. I mean, that's the general idea of the project, but all the values in this case are arbitrary, nothing's measured, but I determined, like a dynamic range of the microphone based on these numbers. And if it peaks over what I consider to be peaking, then it's red. If it's, I can adjust these to change the sensitivity. But it took a lot of getting used to. The code is based on C or C++. It's a stripped down version of that. So I had to reference a lot of things. Most coding languages look roughly like this, but they have little syntax differences that if you don't understand the differences, you end up typing a whole bunch of code that just will throw up errors. So I had to migrate some of my coding knowledge from what I've learned from programming apps in Swift for Apple devices, and I've learned a bit of Java in the past, and a little bit of C++ in the past that I've completely forgotten. That was a decade ago. So learning all this basically was all written from scratch. There's probably 100 different ways of writing all of this way more efficiently with less commands. But at this stage, it's a good beginner's point. To give you an idea of what the LED does, I can actually simulate the volume levels by changing the gain on the actual microphone. I can basically simulate the mic being addressed by different levels of gain. So that's at this point, it's showing up as 102, so that's over the threshold, so you get a blue light. If you were to make a louder volume noise, it would eventually go through to green, and then all the way up through to the red spectrum. So, yeah, and that's basically it. So, what I eventually want to do, I'm not even sure if this level of board is capable of doing it, but I want to create a program that determines the frequency that the microphone's picking up, and then changing the LED to a range of different colors based on that frequency, and then maybe installing that in my guitar somewhere. Because as you can see, the Nano is quite small; it'll fit in a small cavity. And I can put a whole bunch of LEDs on it. I could do fiber optics, a whole bunch of cool stuff. But that's kind of the idea. I don't know if it's possible, but it's always a good challenge to find out. So yeah, that's a little bit about Arduinos. You should check them out. It's fun if you're a nerd. And yeah, thanks guys.